Senator Rennick.
Thank you, Acting Deputy President, and I'm very pleased to rise to speak to this bill because as I listen to the speeches today, there's been very little talk about science indeed. And matter of fact, I haven't even heard of one mathematical equation that actually underpins any of this science since this whole debate started. But I'll get on to that point in a minute. I do want to lay down my credentials in terms of how much I care about the environment. And I want to distinguish the environment and my passion for the environment and the Liberal Party's passion for the environment versus the shoddy mathematical modelling, indoctrination, intimidation of the climate change propaganda. Now, when it comes to looking after our riparian zones and reducing pollution, looking after our biodiversity, our land management, all these things are very, very important. And I stand with the party. It's one of the values of the LNP is to protect our environment. But as I stand here, I get worried because I know what these so-called renewables, which aren't renewables, they are reliables, and the damage that they will do to the environment if they go ahead. I'll give you one example. These wind farms kill both bats and birds. They're killing our apex birds that it feeds down into the food chain, and they're killing our bats. Now, unbeknownst to most people, bats pollinate lots and lots of flowers. Right? So if we're going to go around killing bats, it's estimated that in the US that the wind farms over there kill up millions of birds each year along with millions of bats. And it's been known in other countries, in Scotland and places like that, there's a real anti-wind farm sentiment. They are doing a fantastic job tracking the number of apex birds that are being killed by wind farms. But it just doesn't stop with wind farms. It also is lithium with these batteries and the rare earth mining that has to be carried out in order to build a battery. Now, not many people realise, for example, that lithium is a 1% ore body. You've got to mine 100 tonnes of ore to get 1 tonne of lithium, right? But the thing about a mine is that you just don't. The ore body, you can't just go and dig the ore body out of the ground. You've got to go around and around and around in order to get to the ore body. So that means you've probably got what they call a stripping rate of about 10 to 1. So you would quite possibly, with many of these lithium mines, and don't forget that's just one of the many metals that go into a battery, have to mine 1,000 tonnes of dirt in order to get 1 tonne of metal. But here's the rub. You don't just get the 1 tonne of metal out of the ore that easily. You've got to put it through a number of electrolysis processes to extract the metal from the ore. And then once you do that, you then put it on a ship to China, where it then goes into a battery. From that battery, it then goes into— I don't disagree with that, we should value add debt, but it then goes over to Texas into a Tesla factory where it goes into a car, and then from the car comes all the way back to Australia and then gets used. But having said that, the actual power is put into a wall socket where most of the power actually comes from a coal mine anyway. Now, if you compare that to, say, for example, that Kogan Coal Creek mine close to my hometown of Chinchilla, it's what you call a mine mouth coal mine, which is where the mine is only 4 kilometres away from the power station. And coal is coal. There is no actual extracting coal from the ore body. You burn it, you strip it, you mine it, you put it straight into the power station, and the power is transported via the southern interconnector. It is a very efficient form of producing energy. But it doesn't stop there. These batteries that go into cars weigh up to 700 kilograms. They add a significant amount of weight to a car. They increase the braking distance. They are going to increase accidents. If you do not want to get hit by a 700-kilogram solid object. They are going to increase the rubber burn off in cars and increase the rubber pollutants in the air. This is not going to end well. On top of that, you have to build so much more security services in order to do with the frequency and the volatility control, because we're going to have renewables coming on and off, on and off, on and off. So we're going to have to spend hundreds of millions of dollars on synchronous condensers. Now, they are these big spinning flywheels that sit on an inverter at the end of the coal-powered fire station, and when there's an overload or a surge of too much energy coming from solar, say, for example, that power's then got to get diverted off into the actual spinning wheel, and then if there's a dip in the energy, if that spinning wheel's still spinning, you can divert some of that energy back into the actual the grid. But this all requires a lot of extra costs. There's been a lot of false assumptions. Now, for example, the Cost Gen report assumes that there's no extra transmission required until renewables hit 50% of the grid. Now, that's farcical because the Labor Party have got a $20 billion rewiring the actual grid scheme, so that's going to be a loan, of course, and I don't know what the conditions of that loan are, but that's going to cost a lot of money. So we're now going to have all these extra transmission lines across the country. They themselves kill heaps of birds. That's a well-known fact, and I just can't wait for the farmers to, there's going to be once more and more of these transmission lines start getting built. I know in Western Victoria they're protesting about that at the moment. You're then going to have all these impacts on farmers. You're going to have transmission lines going crisscrossing the country. In the old days when we had 80% of the eastern seaboard powered by coal, we only had about 30 power stations, and it was all very efficient when it came to transmission. Now, on top of that, we've got the problem of recycling. Now, the head of the CSIRO, Larry Marshall, said in estimates it costs 3 times to recycle a battery than it does for the cost of the metals that go into the battery. So I want to know, how are we going to recycle all of these lithium/cobalt/aluminium and copper and all the stuff that go into these batteries? I don't think it's ever going to be economical to recycle these batteries because it is so metal intensive. And this is the big fallacy of all this. All you're doing is shifting from mining coal to mining rare earth metals that are 1 or 2% of the actual Earth's crust. Now, Richard Harrington from the London the head of geology at the London Natural History Museum, has said there is not enough. He was just talking about Great Britain, but there wasn't enough copper, nickel, neodymium and a few other metals on the Earth's crust to actually power the UK fleet. So where are we going to find all these rare metals to actually, basically have enough battery storage so that the renewables, well, I call them unreliables, and they're not renewable. The hardware isn't renewable, right? It's just totally unsustainable. But look, these things are unfortunately, and I've just realised that I'm never going to win this argument. Whenever I talk about this stuff, I'm called a climate denier. I somehow don't care about the environment. I have to say I find that incredibly insulting. As someone who grew up on a farm, who yearns for the sound of the whipbird in the morning or the sound of the glass out at Chinchilla, and the beautiful noises they make, I love the environment. When I was offered a partnership in an accounting firm when I was 23, I turned it down to go overseas. And the first place I went to was Africa. I climbed Kilimanjaro in the first week. I went to see the gorillas in the mist. I went and dived at Zanzibar. I went to the Serengeti. I went to Europe. I climbed the Alps. I rock climbed in the Alps. I then went over to South America, Machu Picchu Trail, Nepal, climbed to Concagua. I've surfed, skied, paddled down so many rivers. I love the environment. But yet whenever I raise these genuine concerns about the environment, you're just castigated with intimidation, indoctrination and shoddy mathematical modelling that somehow, the debate's moved on. Well, let me tell you, the debate hasn't moved on, and it will never move on, because at the end of the day, all science is underpinned by mathematics. And if there isn't a mathematical algorithm that demonstrates cause and effect and quantifies that cause and effect, then that's not science, because behind every good scientist is a mathematician. Okay, and if you go and watch these movies and these so-called science boffins, they're on the wall proofing their algorithm. And that's what I'm going to finish this speech up on tonight, because I want to talk about the scientists. No greater scientist himself than Albert Einstein. And in his 1917 paper on the quantum theory of radiation, and let me quote his conclusion, is that one feels justified in this because the momentum transferred by radiation is so small that it always drops out as compared to that from other dynamical processes. What does that mean? There's 3 forms of heat transfer: convection, conduction and radiation. Now, at the end of the day, Albert Einstein, the great man himself, the greatest scientist that ever lived, said radiation was so small is it insignificant. Okay, so just remember that. So if you want to talk about science and the science of climate change, I say there's no such thing. It's the science of heat you need to focus on, and the science of heat's called thermodynamics. And those rules were first settled 200 years ago by guys like Robert Joule and William Thomson, who later on became Lord Kelvin, who was the first scientist to be made a Lord in the House of Lords 200 years ago. And Leo Carnot, a great Frenchman who actually worked on the second law of thermodynamics, technically speaking it was the first law of thermodynamics because he got to that before Boyle and Joule. But anyway, I digress. But I want to touch on these laws of thermodynamics to actually prove that this whole concept of adding carbon dioxide to the atmosphere is somehow going to increase the heat. Because as anyone understands science knows, E equals mc squared. Energy comes from the combustion of energy in the sun. 600 billion tonnes of hydrogen are burned every second. That's converted into 596 billion tonnes of helium and 4 billion tonnes of energy. Now, radiation energy is carried by a boson known as a photon. Now, some of that photons come here to planet Earth, and it comes about in the form of about 8% infrared above the visible spectrum, about 42% visible spectrum, and about 44% infrared energy. Now, carbon dioxide, ironically enough, only actually absorbs energy at certain frequencies. One of those frequencies happens to be 2.8 microns, which is incoming radiation. Okay? Another frequency it absorbs at is 14.8 microns, which just happens to be outgoing long-wave radiation. Now, here's the thing. If you actually apply Planck's law, E equals hv, that the energy consumed by carbon dioxide on the way in is actually 5 times stronger than the energy absorbed by carbon dioxide on the way out. Okay, because they never want to tell you that, right? What do you think actually slows down the adiabatic lapse rate? If it wasn't for the actual greenhouse gases, and we know this because the maximum temperature in Singapore is about 34 degrees, it's been actually proven that the H2O, water, vapour, actually cools. So if you go to places in outback Queensland or Australia, you'll get 50 degrees in the summer. In Singapore you won't get that because the humidity actually stops the radiation, incoming solar radiation, from getting too hot. It gets very muggy, but that's actually the water, not the radiation. So that's 2 laws. So we've basically broken so far E equals mc squared, special theory of relativity, 1905 by Einstein. He did 4 great papers that year. He didn't actually get a Nobel Prize for that. He got that for the photoelectric effect that he did later that year. And of course we've now broken also Planck's law. But then we go on to Wien's law. Now, Wien's law actually describes the temperature, actually calculates the temperature at which carbon dioxide will actually emit any energy it absorbs. Now, we know that that's basically, what's the word it's called? I did have to print this off, I can't remember this. It's called the constant of proportionality, and that's 2.2898 centimetres. And you actually put that over the wavelength that carbon dioxide absorbs, 14.8 microns, and that will give you 192 degrees in Kelvin. Now, 192 degrees in Kelvin, for those of you who don't know your Kelvin scale, is actually negative 80 degrees Celsius in real life. So in other words, carbon dioxide actually only emits heat at negative 80 degrees. So if you want carbon dioxide to be so-called trapping heat, as you guys like to claim, you'll need to either go to the bottom of Antarctica or about 10 kilometres up in the actual troposphere to actually start getting carbon dioxide to actually emit heat. But here's the thing. You see, carbon dioxide is only ever going to emit what comes in via radiation in the first place via the photons, right? But the problem with that is and that's if you use the first law of thermodynamics, which we'll now go to, is that energy is neither created or destroyed. And this matters because of this rule. It means that carbon dioxide only absorbs energy on a logarithmic scale and not a linear scale. So first law of thermodynamics, if I'm a 1-tonne car and I'm travelling at 100 kilometres and I hit another stationary car that weighs 1 tonne, the most that stationary car can move is 100 kilometres. It can't go at 110 kilometres, right? So likewise, with a photon that is absorbed by carbon dioxide, it only absorbs an existing photon. It doesn't actually increase the overall energy intake that's actually in the atmosphere, right? You cannot do that. But here's the thing, and I'll accept you, this little bit of the climate change theory is right. It will emit radiation in all directions, and some of that, albeit at negative 80 degrees, will radiate downwards. And that's where we use the second law of thermodynamics, which is that the entropy of a system will always increase. Now, if I have a glass of water here, half a glass of water here at 10 degrees and half a glass of water here at 20 degrees, and I tip one into the other and assuming we trap the heat, we will actually end up measuring out 15 degrees of the water will end up at 15 degrees. Now, likewise, if we had a little bit of radiation come down, so let's just say the lower part of the atmosphere, or the one glass went to 9.9 degrees and the other one went to 20.1, and you still tip them into each other, the entropy will always increase. It's still going to level out at 15 degrees. So the point of the matter is that the very small amount of radiation emitted downwards, and it's next to nothing. As Einstein said, it's so small it drops out. It's going to be levelled out by the wind, and we know that. We all know that because every day we see the wind constantly moving. That is the second law of thermodynamics in action. However, so I'm going to have to finish my speech here, sorry, but can I just say I will vote against this bill because it is junk science. It has been based on false lies for far too long, and I will continue to fight this to the day I die.
Authorised G. Rennick, LNP Chermside.